Hello friends, today's topic is concepts of stability by control system subject. First question which I have taken is the characteristics equation of a system is given by. So this is the characteristics equation. So this system is stable or marginally stable or unstable, neither A, B nor C. So what they have asked in this question means, say we have to tell system is stable or marginally stable or unstable. So before answering to this question, let us see some basic concepts. So all of you know that this is S plane, this is the real part axis, this is the imaginary axis. If the pose lies in the left half of the S plane, means system is stable. If the pose lies in the right half of the S plane, means system is unstable. The pose lies on the imaginary axis. So on the imaginary axis, system is marginally stable. There should be single pole per single location, or single pole per single location. So there should be single pole on single location. Okay. If there are two poles on single location, system becomes unstable. Okay. This is the concept. If there are two poles, blue color one pole, let us just assume blue color is one pole, red color is another pole. So two poles are single location. So system becomes unstable. So ramp function, as we know that this function is s square 1 by x square. So two poles at the origin. Therefore system becomes unstable. Okay. This should be only on imaginary axis. If two poles on single location on imaginary axis, then only on imaginary axis, then only system unstable. Okay, on imaginary axis. Okay. There should be single pole per single location, then only system will be marginally stable. Necessary condition for stable system. So there are two necessary conditions for stable system. First one is all the coefficient of a characteristics equation must have same sign. So all coefficient of characteristics equation must have same sign. Okay. And second point is no coefficient should be missing. So in the characteristics equation, no coefficient should be missing. These are the necessary condition for stable system. These are the necessary condition, not sufficient conditions. Okay. So these are the necessary condition. Okay. For sufficient condition, there is a route table. So we know that this is a characteristics equation. Once again, this is a characteristics equation. A naught s to the power n plus a1 s to the power n minus 1 up to a n into s to the power 0. Okay. So route table, how to write route table, all of you know. S to the power n, coefficient of s to the power n means a naught. So I am taking the only even number coefficient a2, a4, a6. So leaving this odd number coefficient. So a2 again leaving like that. Next taking odd number coefficient a1, a3, a5. So how to get s to the power n minus 2 means b1 we have to calculate how. So a1 into a2 minus a0 into a3 divided by a1. Okay. So that gives b1. Similarly b2, a1 into e4, a0 into e5 divided by a1 gives b2. Similarly c1. Okay. b1 into a3, a1 into b2 divided by b1 gives the c1. Similarly c2. So last coefficient s to the power 0 coefficient is an. Okay. If main concept is, if in this first column of route table, we have to see that any sign changes. If there is any sign change here, all are positive, no? Okay. If there is any negative sign comes here, so that means if there is any sign changes in the first column of route table, means system becomes unstable. That means how many sign changes, no? That many numbers of poles in the right of the S plane, right half of the S plane. So system becomes unstable. Okay. Please correctly understand this concept. Number of sign changes in first column of route table number of sign changes in the first column of route table is equal to number of closed loop poles in the RHS of right up side of S plane. Okay, then system will become unstable. Number of sign changes in the first column of route table is equals to number of poles in the RHS of right hand side of S plane. So system becomes unstable. Okay, when we have to check this, only if after satisfying these two necessary conditions, then only further calculation will be proceed. Okay, if any system will not satisfy these two necessary conditions, if any of the system will not satisfy these two necessary conditions, if any of the above two conditions fails, then system becomes then only unstable. There is no calculations, further calculations will not be needed. Okay, so next, for third order system, as you know, this is the characteristics equation of third order system, and this is route table. So a to the power 3 and coefficient a, next odd numbers a to s to the power 1, coefficient c, similarly s2 coefficient b, so d, and s1 we will get, what we will get, bc minus ad divided by b, s1 we will get, s0 d we will get. Okay, so for, as I told before, there should not be no sign changes. There is no sign changes in the first column of the route table. So for this condition, what is the condition? BC minus AD divided by B should be greater than 0. This should be positive. No sign changes means positive. So BC minus AD divided by B should be greater than 0. That means it will be positive sign. Okay, so for that, BC minus AD. So if this condition is satisfied, that means system is stable. So one easy trick is, for stable system, BC should be greater than AD. For system to be stable, BC should be greater than AD. There is no necessity of drawing route table and calculating these all methods. Simply here, what is the condition? BC should be greater than AD. If this characteristics equation satisfy these conditions, then system is stable. Okay, then it is not required calculating all these. If we know characteristics equation, we can only check this condition and we will come to know system is stable or not. Okay, so same. So for stable, BC should be greater than AD. For unstable, BC should be less than AD. So marginally stable, if BC should be AD. So check these conditions and you can easily come to know system is stable or not. Okay, for fourth order system, this is the characteristics equation. For stable system, these are the conditions. These both conditions should be satisfied to stable system. Question is, the characteristic equation of a system is given by, so this is the characteristics equation. The system is stable, marginally stable, unstable, or neither A, B, nor C. So what is the system? You have to tell. So fourth order system, so s to the power 4, 3, 2. So s to the power 1 is missing. So no coefficient should be missing. No, for necessary condition. What is the necessary condition for the stable system? No coefficient should be system. So here is one coefficient is missing. So system is unstable. Okay. So second question is, the characteristics equation of a control system is given below. So this is the characteristics equation. The system is stable, critically stable, conditionally stable, unstable. We have to tell. So first, let's take A, B, C, D, E. So fourth order system, similarly. So for fourth order system, for system should be stable means these conditions should be satisfied. So BC should be greater than AD and D should be greater than B square E divided by BC minus AD. So same. So BC should be greater than AD. Here B is 1, C is 3. So BC should be greater. This condition satisfies. So second condition is D should be greater than B square into E divided by BC minus AD. So this is not satisfying. Okay. So not satisfied. This means system is not unstable. Okay. And this is satisfied. This is not satisfied. Both conditions should be satisfied to system then only system will be stable. Okay. Third question, if the poles of the system lie on the imaginary axis, the system will be, as I told, marginally stable. Okay, on the imaginary axis. The closed loop transfer function of the system is Cs divided by Rs. This is the transfer function of the system. The system is stable, unstable, conditionally stable, critically stable. We have to tell. So characteristics equation is, this is the characteristics equation. So for say third order, is 2 power 3 means third order. What is the condition? BC should be greater than AD, no? So A, B, C, D. BC means this is BC, no? 8 into 98 should be greater than A is 1, B is 2. Obviously it is greater, no? BC is greater than AD, so system is stable. Okay, so there is no necessity to draw the route table and check the sign changing, number of sign changed and all. There is no necessity. Only apply this condition and tell system is stable or unstable. Okay, this is the unstable. Please check the coefficient. Okay, first, then further procedure will be proceed, like route table and all these conditions and all. If any one of these two conditions fails, no, the system will be unstable only. Okay, there is no necessity of drawing route table and all. So next I will explain auxiliary equation, find out in value of k and all. So please like and subscribe my channel. Please support.